Good evening, friends.
Good evening, sir.
Now I am going to give some demo about compiler lab. So, as we know, compiler, we heard about the word compiler. Compiler, what does it do? It will do compiling. Yeah. So compiler is it's also a software. Whatever you are doing is software, which will convert your source program into any other target code. The target code may be assembly code or machine language. Okay. So we are going to see the internal of a typical compiler. Okay. It's not about the specific compiler regarding any particular language. So we are going to see the principles of compiler. What are the principles are involved in a design of compiler. Okay. So just similar like how we are communicating with each other. Okay. By using through some language only we are communicating. It could be English or Tamil. Any language you can take. So whatever I am talking, how you are understanding. So first you should know the language first. What are all the alphabets are there in that language? What could be the characters? What are the strings? Then you should know the meaning of each and every word. And also you should know the grammar. What are the rules to talk? What are the rules to understand? So likewise in compiler we are having certain steps, because whenever I am saying a sentence in English, you have to grasp some meaning from that. Whether it could talk about a person or a time, either it's a past tense or present tense. So likewise there is some meaning for each and every sentence. Likewise we know what is a program. What is a program? Program is from a language, so which will have its own alphabet from that specific language. Okay. So for each and every statement or each and every string in a language will have certain meaning. Right. So first of all, any program, whatever I am giving, that would be scanned properly by the compiler. So to segregate the words like tokens. So that's what the first principle in a compiler is, lexical analyzer. So that will scan the entire program and that will segregate all the tokens, meaningful tokens. So each and every token will have specific meaning. Next, so the scanner will provide you the stream of tokens. Okay, which means the output of the first phase, that is your streams of token, that will be given to the next phase. So now, so whenever you are segregating all the tokens or all the words in a sentence, you have to give some connection between all those words. So now I am teaching something, I am, everything will have some connections in between. Then only it will give you a particular meaning, right? So here next the streams of token will be given to the next phase, that is your syntax analyzer. So that will create links between each and every tokens. So that is syntax analyzer, that will validate that statement whether it is in correct syntax or in that are there any error. Okay, that will be checked by the syntax analyzer. So this syntax analyzer will generate the syntax tree. Okay, so the syntax tree is the validation of your given statement. Okay, if there is any error, it will be given as an error message. If there is no error, so it will be validated and it will give a syntax tree that will be given to next level. So once all the words are correct, now we have to get some meaning, whether it is giving correct meaning or wrong meaning. Okay, that is called your semantic analyzer. So I have to give some meaning for that particular statement. Okay, so that will be checked by the semantic analyzer. Okay, so that semantic analyzer will generate semantic tree. Okay, which means semantically it's correct. Sometimes your words may be correct, but it will give some wrong meaning, right? But here I have to check whether the given program statement is in a respective meaning or wrong meaning. So that will be checked by the semantic analyzer. So now it will generate a semantic tree. So next phase, now I have to convert this semantic tree into the another code, that is intermediate code, that will be understandable by the another phase of my compiler. So that will be converted to intermediate code. Intermediate code may be in various forms. Either it could be 3 address code or POSIX or your directed acyclic graph, tag. So these are all the formats that will be given by the intermediate code. Finally, I have to generate intermediate code. So the whatever generated as a intermediate form, that will be given to the code converter. So that will be, the code converter will convert those intermediate forms into assembly code. Okay, assembly code. So from that assembly code easily you can get, what you can get? For each and every assembly code, if it is move a comma b, we can give some mnemonics. So it will be mapped by the mnemonics table. So the entire program which I have given in a C language, that will be converted to mnemonics. So mnemonics, from that mnemonic easily you can generate binaries. So that will be easily readable by the compiler. Okay, so compiler will give that mnemonics, and the mnemonics can be easily executed by the another loader linker assemblies. Okay, so in this lab we are having 11 exercise. So for each and every exercise we will demonstrate each and every phase. Okay, we are having symbol table. So symbol table, so symbol table is a table which will be organized by the lexical analyzer. So whenever the scanner is scanning the program, whatever the identifier scanned by the lexical analyzer will be stored in a separate data structure. That's like our table. So in that table it will have what is the type of that identifier, what is the name of that identifier, and the starting address. So everything will be stored as a records in that table. So whenever there is a need of the same variable in my program, okay, you are declaring your int a in a beginning of that program, and wherever you are using that a, so automatically the compiler will refer that symbol table whether is there any record for that a. So if there is no record but you are using one variable, what will be the output? You will get a unidentified, okay, undeclared identifier or unidentified variable you are given. Like that, the error will be generated by the error control. So parallelly we are having error control. So I am going to give you the first phase output. So here I am going to explain about implementation of lexical analyzer using lex2. Okay. So normally we can do the same program by using C. So C where you have to give all the codes. Okay, but we are having lexical analyzer which is specifically designed for a lexical phase. Okay. So which will give you what are the declarations you have to do, what are all the regular expression, what are all the rules we have to follow in a language. It's a basic tool. If you know this lex tool, easily you can develop your own compiler. Okay. So this lex tool will segregate what are the tokens which are available in a program. Okay. This is the program, right? So which has three parts always. First one is you have to give like your C program, what are the identifiers, namespace will be given. So that is in this part. Okay. So I am going to use the set of characters. I think some of you know TOC or compiler. Can you? This is known as creating regular expressions. Okay. So I can have this star. This is called clean closure. So by using this rule, I can generate a number of strings of characters. Okay. Or sentences which will have text or numbers in combinations. Do you understand? So this is the rule to create an identifier. Okay, whatever the program I'm having, that will have set of identifiers. Okay, this is the declaration part. And if I include hash, so whatever you are using as hash include, that is preprocessor directive. So that will be preprocessed before to execution. So whatever the header file you have included, the corresponding library files will be added while you are going to execute that program. Okay, that's what we are having hash include stdio for each and every specific built-in functions. Right. So if I include hash in my program, that will be identified as preprocessor directive. For that I have included this line. Next, these are all the keywords. So for variable declarations, for conditional statements, for each and every statement I am having all these keywords. We know all these keywords, right? So that pipeline is R. Okay. So if I either include int or float or character, so that will be taken as a keyword, right? And go to finally this set will be set as keyword. Understand? So if I include either of these string in my program, that will be identified as keyword. Okay. Then if any identifier that is not included in that declaration list, or if I am having some string with double brace, like round off within bracket, so that will be the built-in function. So that will be identified as function. So likewise, I have included all the things. Then I can give all the operators. I can give numbers. So whatever the elements you are including in your program, so that will be identified. Okay. Let me execute this program. So this is actually second part in any Lex program. First is your declarations. Next one is your rules. What are the rules I have found? Fourth one is actual functions. Okay. So which this function will read a set of program from user side, and that will be given to your YYN. That is my Lex input. So that the program will be read by the Lex, and the corresponding scanner will scan all the program characters and tokens, and it will print out the specified or the respective tokens, the which type of that token belongs. Everything will be displayed. This is my input, so I am going to give this input. Okay. So this is my Lex program. I have to save this program as .l. Okay. Lexi.l. I have saved this. Then I have to take the input file. So I have taken the lexical analyzer and the input file. That is the input for my lex. Now I have to compile my lex program and I have to run that.